Okay, good morning again to everyone. So I'm going to supplement what we have learned on two-port systems approach to BJT amplifiers. So here's another example of a BJT amplifier. Kaya akong emphasize, no? So this is our BJT amplifier, right? Ano siya? Nga later, pwede na ito ma-simplify as just a black box, no? Or a two-port system characterized by input impedance, output impedance, and gain. Okay, so that's our amplifier. This part here is our source, and this part here is our load. And as for the amplifier, this is an emitter bias amplifier. Okay, so we're going to solve these three. First, determine the no load voltage gain, input impedance, output impedance. Next, we're going to sketch the two-port model from the values that we've determined from part A. And also, we're going to determine AVL and AVS because our amplifier is connected naman agad to a load and a source. Okay. So exactly the same naman I think na sa katong example sa previous na video, but emitter bias lang eh. So the first step siguro guys is, of course, you should have your table of formulas ready. So, diba? Ako naman tanan na-upload sa atong class notes. Wait na sa Okay. So na-upload na ko tanan sa class notes. Have your formulas ready for DC, for AC. Naman pa. And the two-port systems nga mga formulas, this one. At least these two, no? Kaning AVL and AVS. Okay, so have them ready. Ana, we are going to easily solve this problem. Okay, emitter bias. Again, dapat ready na ang table for DC. DC analysis. Okay. So, prepare lang kong lahi nga screen nila sa akong other device para din ako sa ligkuan. Alt-tab. The idea is dapat ano yung tulo, no? Kani and kato. This one. So first off is we're going to solve for IB. So mahulog yun nga mag-bike kita sa sugod. No? Pero sige lang, okay. Ready naman po na nga itong mga formula. IB is equal to, going to refer to the table. So DC analysis. IB is equal to VCC minus VBE all over RB plus beta plus 1 RE. So this is 18 0.7 all over 680K plus beta is 110. So 111 times RE is 0.82K. So 820 ohms, right? So solving for IB, we'll obtain a value of Sa mga 22.44 microamperes. 22.44 microamperes. Okay. If that is IB, you can obtain IE. IE is beta plus 1 IB. IE is 110 or 111 times 22.44 micro. Therefore, IE is nasa mga 2.49 or 2.5. Okay, 2.5. 2.49 milliamperes. After IE, what's the next class? Small RE. Small RE is 26 millivolts over IE. So RE is, kung milli na sila duha, pwede lang niya siya 26 over 2.49. Millivolts man eh. Kani milliamperes. So later, pwede lang na siya 26 divided by 2.49. Therefore, RE is 10.44. 10.6 divided by 2.49. Ohms. Okay. I think we're ready for our AC analysis. ZI. RB parallel ZB, where ZB is beta RE plus beta plus 1 RE, big RE. Check ako again formula ba? Oh, unbypassed. Okay, so so this configuration is, notice wala ang kuan, okay? Wala ang capacitor here. Although wala may relative na difficulty involved, but we'll just take note that this is an bypass emitter bias. So if we are going to refer to the formula, dili na siya pwede gamiton ng fixed bias, no? Okay, pwede na siya gamiton ng fixed bias kung ang emitter bias na to is na bypass capacitor, but since it's unbypassed, we'll use this one. Nalaman nun gyapon dire. So nothing to worry. Unbypassed emitter bias. So muna yung formula. So let's check, is RE greater than RE? Yes, diba? But we'll try to use though a more accurate na formula. So we'll use this one, RB parallel ZB, where ZB is beta, small RE plus big RE. Kaning second line, first and second lines. RB parallel ZB. ZB is beta, RE plus RE. It's RB parallel ZB, but ZB is equal to, so to, beta RE plus RE. Small RE plus big RE. 110, RE is 10.44. Small RE is 820. Therefore, ZB is 10. Sa mga, okay. 91.35K. 91. Therefore, ZI is RB parallel ZB. So 1 over RB is 680K plus 1 over 91.35K. ZI therefore is equal to 10.44. Wait, let's save a computation again. 1 over 680K plus 1 over 91.35K. 80.53. Okay. Okay, 80.53K. Next, ZO. Okay. If I'm not mistaken, ZO is RC gapon. Yeah. Since what I given na RO, small RO, we'll assume the device output impedance to be infinity. Therefore, ZO, sorry, ZO is approximately equal to RC. ZO is equal to 3K. Last, voltage gain from the table. So since nana si RL and RS, this is the no load voltage gain. So unbypassed emitter bias. Okay. So RC over negative RC over RE, or RE plus RE. So negative RC over RE plus RE. Negative 3K over 10.44 plus 820. Therefore, AVNL is equal to 3.61, negative 3.61. Negative 3.61 unitless because gain man siya. Okay, so that's for part A. Determine AV and L, ZI, and ZO. For B, sketch the two-port model. It's just easy as this. Ito yung tawag black na box or system. So ito ka input pins. Ito ka output pins. Ito na ito ditong ang mga characteristics atong system. ZI, ZO, AV, no load. So 80.53K, 3K, and negative 3.61. Ano na siya ang part B? This is part A. Okay. So far, before I proceed, any questions?
So far, sir.
So far, okay. Thank you. Last, so to? Determine AVL and AVS. So very easy. Both are voltage divider formulas lang. Allow sa to. Nasa pikas ng notes. Wala. Okay. AVL is AV and L RL over RL plus 0. Okay. So AVL negative 3.61. How much is RL? 4.7K. So 4.7K over 4.7K plus 3K. Before I proceed, class, if only ZO is as small as possible, AVL would be equal to AV and L. How is that? So in ideal conditions, we'd want our amplifier to have an output impedance of 0. So if 0 na siya, RL will be divided by itself, RL. So yeah, AVL would be AV and L. So if the output impedance is just 0 or very low, the system will not be affected by the load. Pumunta na ang a very ideal condition. But this is not an ideal condition man because our output impedance is 3K. Dako lang ni siya. So sige lang, no? Side note lang to siya. Therefore, AVL is equal to times 4.7 over 4.7 plus 3K. So, negative 2.2. So, nigamay, no? Nigamay ang atong gain tungkol sa load. So, in designing amplifiers, that's one of the very important things to consider. The value of the load. Last, AVS. Voltage divider formula lagi aton. ABS is equal to, since nano tayo ABL, we could use this second formula. No? Now we use the third, pero naman si ABL, we use the second formula. ABS is ABL times ZI over ZI plus RS. ZI over ZI. So ABL ZI over ZI plus RS. Negative 2.2. How much is ZI? So 80.53. Okay. For 80.53K plus how much is RS? 0.6K. 600. May tayo. So I think dili ra kaayo maapektuhan sa source ng atong amplifier. So multiply lang negative 2.2 by 80.53 over 80.53 plus 0.6. It is 2.18. 2.19. No? Lalagi kaayo. Apektuhan. 2. So the idea also here is that in ideal conditions, when ZI is a very large value, infinity, dili maapektuhan ni RS ang atong gain. So this case is an example of an ideal condition. Dapat naman kayo atong ZI, input impedance to 80K, whereas our source impedance is just 600. Gamay kaayo. So notice nga ang loaded gain of source na gain is almost pareha ra. Okay? Is it clear? So all the formulas that I've used are just here. Nasa kanila notes. Any questions?